Hello, everyone, and welcome to another episode of my reviewer series focusing on geotechnical engineering problems. For this situation, a soil sample weighs 14.46 newtons and has a volume of 0.000991 cubic meters. The specific gravity of the soil is 2.6, and the volume of air is 0.000167 cubic meters. Given that, we are to determine the following: the dry unit weight of the soil mass, the void ratio, the degree of saturation, and the unit weight of the soil if it is fully saturated. To start, let us familiarize ourselves muna with the properties that we are trying to look for. For number 1, ang hinahanap natin is yung dry unit weight ng soil mass. And we all know that our general formula for unit weight is just the weight over volume. For dry unit weight specifically, ang need natin is yung weight ng soil solid, since dry nga, over the total volume. But given our figure, di pa kompleto yung data natin, so di pa tayo makakapag-plug agad sa mga gagamitin nating formulas. So para convenient all throughout sa discussion natin, kompletuhin muna natin yung weight and volume data natin. And in order to do so, magte-derive tayo by using the relationships of our given data. Bale, to elaborate the figure nga pala, yung VW and WW stands for the volume and weight of water respectively. Yung VS and WS naman is the volume and weight of the soil solid naman respectively. Looking at our volumes, meron tayong values for the volume of air and total volume. And alam naman natin that the total volume is just equal to the air, water, and soil volumes combined. Writing that in equation and plugging in our present values, we will set the written expression as our equation 1. Pagdating naman sa weight ng mga elements ng soil natin, as usual, set as 0 na agad ang weight ng air. Take note, yung figure na nakikita nyo sa presentation is just a visual aid para mas madali maintindihan yung relationships ng soil properties. There may be chances na mabigay yung ganitong klase ng problem without providing any figures. So, be mindful talaga sa mga considered conditions and assumptions na standardized na. Going back, equating to our total weight, which is 14.46 newtons, we just add the weight of soil solids and the weight of water present in the soil mass. At this point, ang gusto natin mangyari sa equation na to is dapat marelate natin siya sa equation 1. Para magawa yun, gamitin natin yung relationship ng weight and volume by means of unit weight. Kung bakit in terms of unit weight yung gagamitin? Kasi determinable din yung values nila. Para mas madaling maintindihan, walkthrough na natin kung paano mabubuo yung second equation natin. So napag-usapan nga natin kanina na ang unit weight is just weight over volume. Transforming this, pwede natin siya i-multiply both sides by phi para makuha ang expression na weight equal to volume times unit weight. So pwede natin yun gamitin in terms of both water and soil solids. Defining further, alam natin na ang unit weight ng water in terms of newtons per cubic meter is 9,810. And para naman sa unit weight ng solids, since wala naman tayong given na standard unit weight para dito, utilize natin yung iba pang mga given values. Meron tayong given na specific gravity of 2.6. And if we recall correctly, our specific gravity is equal to the unit weight of a given substance over the unit weight of water. Therefore, we can transform this in terms of the soil as the substance, thus giving us the formula of unit weight of soil solids equal to specific gravity times unit weight of water. Simplifying our equation, ang unknown variables na lang is yung volume of water and solid, similar to equation 1. At this point, set na natin to as our equation 2. And pwede na natin isolve both equations simultaneously. After calculating, this gives us the volume of water of 0.000418 cubic meters and the volume of soil solids of 0.000406 cubic meters. For our remaining unknown data, gamitin lang natin ulit yung formula ng weight equal to unit weight times volume. So for weight of water, volume of 0.000418 times unit weight of water na 9810 newtons per cubic meter. And we will get 4.10058 newtons. Tapos, for weight of solid solids naman, multiply lang natin yung 0.000406 cubic meters by the computed soil solid unit weight, which is 25,506 newtons per cubic meter. And we will get a value of 10.36 newtons. So finally, pwede na tayo mag-proceed sa pag-solve ng problem 1 natin. Sabi ko nga kanina, ang dry unit weight natin is just the weight of soil solids over total volume. So, plug in lang natin yung values and we'll get 10,449.481 newtons per cubic meter. Or converting it to a much simpler form, the answer is 10.45 kilonewtons per cubic meter. Next naman, our void ratio is just equal to the volume of voids over the volume of solids. And as we all know, the volume of voids is just equal to the volume of water and air combined. Kasi yung tinutukoy lang naman na void is yung mga butas na pinaglalagyan ng mga tubig at space. Applying that to our formula, makukuha natin si void ratio by quantity of VW plus VA or yung volume of air over Vs. This will give a void ratio of 1.44. And take note, unitless tong property na to kasi from the name itself, ratio value lang ang hinahanap. And upon solving, magka-cancel lang din naman yung volume units. Moving forward, the degree of saturation can be determined by dividing the volume of water by the volume of voids. So, parang similar lang sa kanina. Plug lang natin yung values natin and we'll get a value of 0.7145 or in terms of percentage, 71.45% ang magiging final answer natin. For our last problem, there are actually two ways kung paano natin pwede makuha yung saturated unit weight. One is involving this given weight and volume values, and the other one naman is by utilizing standard formulas na nag-involve ng ibang present na soil properties. And para ma-familiarize kayo lalo sa mga relationships na pinag-aaralan sa topic na to, pasadahan natin yung parehong methods. Starting with the solution na involved yung weights and volumes, una muna nating i-consider na magbabago yung total weight sa problem natin. Kasi filling in the spaces na initially occupied by air, madadagdagan ang weight of water pag naging fully saturated na siya. And given ang formula for unit weight is weight over volume, need talaga muna natin ma-determine yung bagong total weight ng figure natin. In doing so, denote muna natin yung bagong weight of water with an apostrophe symbol. And using weight equal to volume times unit weight, set natin yung volume as yung initial volume ng water plus yung previous na volume ng air kasi dun lang naman yung space na paglalagyan ng additional na water content. Then times 9.81, which is yung unit weight ng water in terms of kilonewtons per cubic meter, we will arrive at the value of 0.0057 kilonewtons. Solving for the new total weight, which we will also denote with an apostrophe, add lang natin yung 0.0057 and yung volume ng soil solid, which is wala namang nagbago, 10.355 newtons pa rin naman, Pero convert natin ito into 0.010355 kilonewtons. Kasi yung bagong weight of water natin is in kilonewtons. That gives us a total weight of 0.016094 kilonewtons. Now, meron na tayong bagong total weight. So, i-divide lang natin siya sa total volume para makuha yung saturated unit weight. Doing so, we will arrive at a value of 16.24 kilonewtons per cubic meter. This time, proceed naman tayo sa paggamit ng alternative solution. And kaya ko rin to gusto i-discuss kasi mas mabilis lang to gawin compared sa solution 1. Kasi for this method, literal na magpa-plug lang tayo ng values. Performing the problem, saturated unit weight is just equal to quantity of specific gravity Gs plus void ratio E times gamma of water. Then divided by 1 plus E. Then makukuha na natin yung same value as solution 1. So it is more preferable talaga kung aaralin nyo rin mabuti yung mga phase relationships and kung paano nabuo yung mga formulas like this one. If you wish to know more or understand this topic further, I'll be sharing discussions soon in this channel, so stay tuned lang kayo guys. But for now, that's it for this situation.